Welcome to Understand the Math. In this video, I'm going to show you exactly how to easily find all solutions to this trigonometric equation with multiple angles. We'll now solve the equation 2 cosine 2 theta plus 1 is equal to 0. We'll begin by reducing this equation to cosine 2 theta is equal to a constant. We start with 2 cosine 2 theta plus 1 is equal to 0. We'll take the 1 to the right-hand side. So we get 2 cosine 2 theta is equal to minus 1. Dividing both sides by 2 gives us cosine 2 theta is equal to minus 1/2. This tells us that 2 theta is the arc cosine of minus 1/2. Since minus 1/2 is negative, 2 theta is going to be located where cosine is negative, and that's in quadrant 2 and in quadrant 3. 2 times our reference angle in quadrant 1 is going to be pi over 3 because arc cosine of 1/2 is equal to pi over 3. Our solution in our second quadrant is going to be 2 theta is equal to pi minus 2 theta sub r. So this gives us pi minus pi over 3, which gives us 2 pi over 3. Our solution in our third quadrant is 2 theta is pi plus 2 theta sub r. So this is pi plus pi over 3, which is 4 pi over 3. Let's now write down what we got from our step 3. We found that 2 theta in quadrant 2 was 2 pi over 3, and in quadrant 3, we found that 2 theta was 4 pi over 3. Our solutions for all theta are 2 theta is equal to 2 pi over 3 plus 2n pi, because cosine is 2 pi periodic, and then we have 2 theta is equal to 4 pi over 3 plus 2n pi. We'll now divide by 2 to get theta. So theta is going to be pi over 3 plus n pi. And then theta is going to be 2 pi over 3 plus n pi. And n is equal to 0 plus or minus 1 plus or minus 2. Since k is equal to 2, we're going to get 2 solutions for each value of theta for a total of 4 solutions. When n is equal to 0, we're going to get pi over 3 and 2 pi over 3. These are n is equal to 0, and then when n is equal to 1, we're going to get 4 pi over 3, and then 2 pi over 3 plus pi, which is 5 pi over 3. And these are for n is equal to 1.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.